Welcome to the Deep Dive, where we take a stack of information and try to get you right to the heart of what's important fast. Today we're going way back, really ancient journey stuff, all the way to 6th century BCE Miletus. We're exploring the ideas of a philosopher you might not know much about, Anaximenes. We've been digging into a really fascinating scholarly report called Anaximenes, Heirs Arch Report, plus, the usual fragments and reports from later folks like Plato and Aristotle. Our mission today, to unpack how Anaximenes, who was the third big name in the Ionian Milesian School, didn't just pick air as his main thing. He actually gave the world maybe the first comprehensive, observable theory of change. It really shook things up. So get ready for some surprising facts, maybe some aha moments about how science itself started taking shape.
Yeah, it's incredible when you think about it. Anaximenes is right there at the dawn of Western thinking. He's part of this huge shift, this deliberate turn away from explaining the world with myths. Instead, they started using systematic inquiry, grounded in observation and reason. And you'll see how his ideas, even though they're ancient, they laid down groundwork that, well, still resonates today, really does.
Okay, let's unpack that. So Anaximenes didn't just pop up out of nowhere. He was part of this amazing line of thinkers in Miletus. He followed Thales and Anaximander. But first, what was Miletus like? Back in the 6th century BCE, what made it this hotbed for rational thinking?
Well, Miletus was buzzing. It was this major hub for sea trade. It connected the Greek world with huge empires like Egypt and Persia. And it wasn't small time. It had over 90 colonies, a real powerhouse. So this trade created a very cosmopolitan vibe. Think of it like an ancient marketplace of ideas, really dynamic. And unlike mainland Greece, it had this sort of frontier spirit, less rigid religious rules,
Huh. Almost like an ancient world Silicon Valley then. A place for big, new ideas to take root.
Exactly. That's a good way to put it. And that environment, plus having a class of people with leisure time, the aristocrats, it allowed for this radical attempt to explain the world using its own principles, defining nature by nature, not by myths about gods. That's the Milesian Revolution right there. This search for one single underlying principle, the archē.
That makes a lot of sense, setting the stage. But what about Anaximenes himself? You mentioned fragments, later authors. We don't actually have his original books, do we?
No, that's right. That's a key challenge, actually, for all the pre-Socratics. We piece together his ideas from, well, fragments like actual quotes saved by later writers and testimonia. Testimonia are basically reports or interpretations from people like Aristotle and his student Theophrastus, who came later. And the thing is, these later writers often looked back at the pre-Socratics through their own philosophical lenses, their own agendas. So part of our job now is kind of peeling back those layers of interpretation. We're not just finding out what he said, but also how giants like Plato and Aristotle read him. It shows how our knowledge is sort of refracted.
Filters, like historical detective work. Okay, so we've got Miletus as the backdrop. Let's get to Anaximenes' big idea.
Yeah.
He picked isis air as his fundamental principle, his arch. Now, to us, air might sound, I don't know, a bit simple, maybe even basic, but it was more than just, the air we breathe, wasn't it?
Oh, much more, yeah. For Anaximenes, aeser was broader. It covered mist, vapor, even the breath of life itself, pneuma. It was one thing, and it was infinite, kind of like an Anaximander's apron, his boundless principle. But the crucial difference, Anaximenes the airs was definite. You could recognize it, you could observe it, and it was always moving. That was the ultimate cause of change. Choosing it here was actually pretty clever. It combined the observable stuff, like Thales' water, with the infinite, all-encompassing idea from Anaximander's abstract abron. It was like a perceptible infinite, something real, tangible, but still boundless.
And here's where it gets really interesting, I think. He didn't just say air was the basic stuff. He said it was divine. There's that quote, right? That from Aesir, the things that are and have been and will be, the gods and things divine, took their rise. So the gods themselves come from air. How does that work with a natural explanation?
Yeah, that's a huge step. It's basically the naturalization of the divine. Think about it. The traditional Olympian gods, Zeus, Hera, all of them, they get demoted. They're not the ultimate creators anymore. They're just products of this fundamental substance, Asher. So the real divine principle for Anaximenes isn't some moody god on a mountain.
Yeah.
It's this impersonal, eternal, all-governing Aesir. And that raises a really deep question for us, even now. How do you square a divine primary substance with a view of the cosmos that seems pretty mechanistic? It hints at this connection between, well, physics and something deeper right from the start of Western philosophy.
That is a fascinating tension. Okay, but just naming a principle water, the boundless air isn't the whole story. The real breakthrough is explaining how everything else comes from it. Did Anaximenes offer that?
Yeah.
A clear mechanism.
Absolutely. And this is probably his biggest contribution, the thing that really makes him stand out. He proposed a specific, universal, and this is key, observable mechanism. Condensation, pukishis, which means thickening, and rarefaction, manusis, thinning it out. He argued that basically everything is just different states of a two-seer made by these two processes.
Okay, so walk us through that. How does it work? Air becomes what?
Right. So when a seashore gets rarefied, thinned out, it becomes fire. Think lighter, hotter. When it gets condensed, thickened, it becomes in order. Wind, then clouds, then water, then earth, and finally stones. Solid stuff. And it's not a one-way street. The whole process is reversible. It creates this whole continuum of matter.
Wow. Okay, so he wasn't just saying this stuff. Did he have any evidence? Any examples we could relate to?
He did. And they're brilliantly simple, everyday things. There's the famous breath experiment. If you breathe out with your mouth wide open, the air feels warm, airly. That's rarefaction, he said. But if you purse your lips and blow, the air feels cold. That's condensation. Now, okay, his physics about temperature was actually the reverse of what we know now.
Okay.
But the method, that was the point. Using a simple observation to back up a huge universal idea, he also used the analogy of felting. You know how you take loose wool fibers and press them together into dense fabric? He saw that as a model. How one substance, just by being packed together differently, changes its properties completely.
That's really clever in its simplicity. So what's the big takeaway here for science? He was basically saying that the things we see as totally different qualities, like hot, cold, wet, dry, solid, gas, they're really just differences in quantity, just how dense the astrophere is.
Precisely. Exactly. I mean, think about how radical that was. Before him, the idea that fire and rock could be made of the exact same stuff, just one less dense, one more dense. That's mind-blowing for the time. It's really the blueprint for how physics understands matter today, in a way. This core idea that qualitative change comes down to quantitative change, it became foundational for all physical science that followed. It cleared the path for things like atomism later on, the idea that one variable density could explain so much diversity. It's huge.
And he didn't stop there, did he? He applied this archē's idea to the whole universe. How did he picture the Earth and the sky?
Yeah, he extended it outwards. He thought the Earth was like a big flat tabletop disk formed by a Caesar condensing. And unlike Thales, who thought it floated on water, Anaximenes famously said the Earth rides on air because it's flat and broad, like a lid or maybe a leaf floating.
Rides on air. Okay. And what about the sun, moon, stars? Same idea.
Pretty much. They were also flat, fiery things, and they also ride the air because of their flatness, like leaves on the wind. That's the image. He thought they came from damp stuff evaporating from Earth, which then got rarefied, thinned out into fire. And there's even a hint, some scholars think, that he might have distinguished the fixed stars from the planets, the wandering stars, which, if true, would be an absolutely massive leap in astronomy for that era.
And he even used this one mechanism, condensation and rarefaction, for things like weather, taking it away from the gods being angry or happy.
Yes. That really shows his drive for a unified system. Everything explained by the same process. Wind. That's just condensed ashes moving around. Clouds, rain, hail, snow. Just a desert getting progressively denser. Thunder and lightning. He thought it was wind trapped inside clouds breaking out violently. Rainbows. Just sunlight reflecting off thick, condensed air. Even had a go at earthquakes, saying the earth cracks when it gets too dry or swells up when it gets too wet, causing tremors. It's this powerful push for consistency. One idea explains it all.
So looking back at the Milesians, Thales, Anaximenes, how does he fit in? Going back to a concrete thing like air after Anaximenes' abstract boundless, was that a step backwards or forwards?
That's the classic debate, isn't it? And scholars still argue about it. Some did see it as a step back, a regression, because Anaximenes' apparent seemed to solve this logical puzzle about how opposites could come from one thing. But the other view, which has gained a lot of ground recently, is that Anaximenes' real genius was giving the physical mechanism, the how. Condensation and rarefaction showed how one substance could actually physically turn into its opposite. It made that whole Ionian natural philosophy project much more, well, scientific, more grounded in observation. So you could see him as cleverly synthesizing the strengths of the guys before him, bridging that gap between the abstract and the observable.
Right, right. And there was also that really powerful analogy he used connecting us humans to the whole cosmos.
Yes, and it's powerful because it's the only direct quote we have left from him. His actual words, he says, just as our soul, psyche, holds us together, so do breath, pneuma, and air encompass the whole world. So he identifies our soul, our life force, directly with his air, links life and breath. and then he scales it up. It's a microcosm, macrocosm thing. The whole universe is like a giant living thing, breathing the same divine ease that keeps us alive. It even suggests that, looking inward, thinking about our own breath, could be a way to understand the cosmos.
That's a really profound thought, the universe as alive. And his ideas, they spread, didn't they? How did he influence later Greek thought?
Oh, profoundly, hugely influential. Thinkers like Heraclitus definitely picked up on his model of cyclical change, constant transformation. And later on, the pluralists, the atomists, they carried forward that mechanistic approach, explaining change through basic bits interacting. Even the big guys, Plato and Aristotle, they engaged really deeply with Anaximenes' ideas, though, as we said, they had their own takes on him. What's fascinating is that tension in his thought. On one side, it's very mechanistic, condensation, rarefaction, density. But on the other, it's vitalistic, almost panpsychist, this idea of a sister being divine, alive. And later philosophy kind of split along those lines. You had the atomists taking the mechanistic path and the Stoics leaning more into the vitalistic, living cosmos idea. He really planted both seeds.
It sounds like scholars today are really giving him his due, maybe seeing him as more central than before. What are the big debates about him now?
Absolutely. Modern scholarship sees him as pivotal, especially that theory of change. One ongoing debate is about the azer itself. What did he really mean? Was it clear, invisible air, like we think of it? Or, as some linguistic analysis suggests, was it more like an opaque, damp mist or vapor? A kind of fertile, generative substance right from the start that changes things. Another discussion is about that divinity. What did divine mean to him? Was it just a label for the eternal first principle, kind of stripped of religious meaning? Or was it a stronger pantheism? Did he think a cancer was an intelligent force guiding the cosmos?
And you mentioned Plato and Aristotle's interpretations. That's still a hot topic.
Oh, definitely. Maybe the biggest controversy. Aristotle mostly presented him as a material monist, meaning air just stays air, it just changes form. But there's influential modern work, particularly by Daniel Graham, arguing Plato actually remembered an older, maybe more accurate view, that Anaximenes was more radical, a process philosopher, where transformations are real, things genuinely come into being and pass away, reality as constant flux.
And this isn't just splitting hairs. It gets to the heart of how the pre-Socratics were grappling with the fundamental nature of change itself. It shapes how we read that whole foundational period.
So as you can see, Anaximenes of Miletus, he's not just some dusty footnote. His choice of izer, air might seem simple now, but his real genius wasn't the what, it was the how. He was the first thinker we know of in the West to propose a specific, observable, universal mechanism, condensation and rarefaction, to explain all material change. And by grounding that mechanism in those simple, relatable analogies, the breath, the felting he took thinking about the cosmos and turned it into something with the real marks of science, observation, analogy, looking for unified laws. And that move, reducing quality to quantity, saying heat or hardness is just about density, that's a cornerstone premise of physical science that's still with us today.
He really pushed for a new way to ask questions, based on looking, comparing, searching for natural rules that applied everywhere. He helped solidify the very foundations of rational inquiry. Its influence is just immense.
And if you want to connect it to the bigger picture, Anaximenes really makes you think about how we define life or mind in the universe. I mean, if the whole cosmos is alive, breathing the single divine air, and that same air is our soul, what does that say about how connected everything is? Right down to the physics. It blurs the line, doesn't it? Between a purely material explanation and maybe a deeper, almost spiritual sense of reality. Makes you wonder how much of that ancient breath of the cosmos is still kind of embedded in how we see the world, even with all our modern science.
And that is our deep dive into Anaximenes. We hope you feel a bit more informed and maybe, just maybe, a lot more curious about the air all around you and the air within you.